Okay, everyone, this is the first lesson for pre-algebra, area of combined polygons. And like I said earlier, said today on Sunday, this is the most challenging section. So even if you have trouble with this section, you're going to find that the next three sections are a lot easier. So just do your best with this section, give it a good effort, and make sure you go on to the next. So look at the first concept. Let's find the area of this polygon. All right, and notice this polygon is it's a quadrilateral, meaning it has four sides, but it doesn't have a name. You know, we don't know what this is. This is it looks like sort of like a rectangle, sort of like a triangle, and that's what you do. You sort of cut it into pieces so that you can find the area of all of it, of the pieces, and then you add up the two pieces. Okay, so for example, I look at this figure here and I see, I don't necessarily see, it'd be difficult to see how to do an area of that thing without cutting it into things that I know of. Okay, for example, I know the formula for the area of a rectangle. Okay, I know that formula. That is area is equal to length times width. I know that the area of a triangle is 1/2 base times height. So what I want to do is I want to cut this into either a triangle or a rectangle or both, and then I can find the area of those things and then add them together. And that's what I'm going to do to this one. I'm going to cut this one right here, okay, and that's going to give me exactly what I want. It's going to give me a rectangle, okay, see the rectangle, and it's going to give me a triangle. So I can find the area of the rectangle and the triangle and then add those two together. So for example, the area of this rectangle is just length times width. So you want to make sure you find the two sides of the rectangle. Here's one side, 4, and here's the other, 6. So 4 times 6 is 24 centimeters squared. There's the area of this, of the rectangle. Now I want to find the area of the triangle. The area of the triangle is 1/2 base times height. Well, the base down here is the length of this. I look across, there's 6 from here to here. 8 goes from all the way across, so I would just subtract 8 minus 6. That's going to give me 2. That's what this is. And then the height, I look across the rectangle. Rectangles have the same length on opposite sides. So that one's 4, so that would have to be a 4. So that would be 4. So we'll apply our formula. Area equals 1/2 base, which is 2, and 4. So 2 times 4 is 8. Half of 8 is 4. So that area is 4 centimeters squared. Now I have my two areas. I would add them together to get the area of the entire figure, which should be 28 centimeters squared. And that's the answer. Okay? And that's what I'm doing each time. I just want to cut this thing into pieces. Okay? Cut it into pieces. All right? 28. Okay, now for this one is a little bit different because what you're going to have to do is you're going to have to use what's known as the Pythagorean theorem. Okay, Pythagorean theorem. And I'll show you what that looks like. All right, so we have our figure. Here's one side. Here's another. Here's another. And finally, there's the last. Okay, and this is a little, and here's a little, these are our little right angles here. Okay, all right. So this is 100 feet. Here's 60. Here's 110. Okay, we want to find the area of this whole figure. So what you need to do is first do your little cut to cut it into a rectangle and then also a triangle. Here's my rectangle, here's my triangle. First, we can easily find the area of the rectangle. Length times width. 100 times 60, which would be 6 6,000. That's feet squared. Okay. Then the other one, we need to find the area of this triangle. Remember, what we need for that is the base, which is the big thing at the bottom. We don't know what that is yet. And the height. And the height, look across. The rectangle, the opposite sides of the rectangle have the same. So we know that's 100. So area is 1/2. Base we don't know yet. Height is 100. Okay. The other part of this that we're going to find is, if we know this is 110, this is 100, this is a right triangle. So we can apply the Pythagorean theorem. And the Pythagorean theorem states that if you take the longest side and you square it, that's equal to the other two sides squared added together. So the longest, the hypotenuse squared, is equal to 100 squared plus a squared, which we don't know. We don't know a squared yet. Okay? So let's go ahead and do this. So 110 squared, 110 squared, let's use our calculator here. So let's go ahead and do that. 110 times 110 is equal to 12,100. 12,100. 100 times 100 is 10,000 plus a squared. Go ahead and subtract that. So that would be 2,100 is equal to a squared. So now we need to take the square root of 2,100. Okay? Square root of 2,100. And I believe it's close to 36. No. What is it? So yeah, right. We take the square root of this. Okay, so make sure you the square root symbol on your calculator looks like this. So you take the square root of 2,100. That's going to give you a. So that's going to be close to 46. Okay, so that's 46 goes here. Okay, and you're not done. You need to find the area of that that triangle. So area is 1/2 base, which is B, 46, times height, which is 100. So area is 1/2. 46 times 100 would be just 4,600. Half of that is area is 2,300 feet squared. Add those two together. Okay, add 2,300 and 6,000 together, and you get your answer, which is the area of the entire thing is 8,300 feet squared. Okay, so that's what you do. You make the cut, find the area of the rectangle, area of the triangle, and then you are done. Okay. Cut. Okay. So example 3 involves the proportions. Okay, and we have talked about proportions before. Once you have the proportion, you notice they have the longer leg. So for example, ACD. Okay, ACD is the longer leg of the triangle ACD is 40 over the shorter leg, which is 30. So 40 over 30. So they do the same thing with the small triangle. 20 over x. Okay, and what do you do here? You know how to do this. You cross multiply. So that would be 40x is equal to 600. Okay, and then you would divide that. Okay, the other way to do that is think of 20 times 2 would give me 40. What times 2 would give me 30? X would be 15. Okay, all right, and so for the perimeter you would add all those up to get 90. For the area, remember, area of this ACD was area is 1/2 base times height. Okay. All right, so go ahead and try the practice set. All right. These are two of the ones that you cut. Okay, here is the one like this example, the third, and finally here is one that's that's already cut, you're probably going to have to use the Pythagorean theorem. Go ahead and give your best effort. Like I said, this is a difficult lesson. Go ahead and give it your best effort, and also on the reteaching. Okay? Good luck.